So this video is going to be a recap of all the different angles that you can measure on a coordinate plane and how most of the math world does these things. So the first thing is to talk about an angle in standard position, and we always consider the positive x-axis our 0 degree axis, and that would be sort of where our angle begins. Sometimes this is called the initial side of the angle. And then wherever we stop is called the terminal side. Okay, so let me just make one up here. All right, now right here, if this is my angle, initial side and terminal side, the angle is measured counterclockwise if you're using positive degrees. So that looks to be about, let's see if that's 90, maybe this is about 110 degrees. So that would be my angle. This is the angle in what's called standard position. Initial side, terminal side, standard position. Now, if I wanted to give this angle another name, I could still start at the initial side, but I could go clockwise around the circle. And when I go clockwise, guys, I still have a degree measure, but I'm measuring in negative degrees because I'm going around the circle in quote-unquote the wrong way. All right, so if a whole circle's 360 and I take away 110, that's going to be a distance of negative 250 degrees. And these two angles, they relate to each other because they both have the same initial side and they have the same terminal side. The only difference is I was looking at my picture a little differently, but because they stop in the same place on the circle, these two are said to be coterminal angles. Now, any angle on the coordinate plane has an infinite number of coterminal angles because we could actually keep going around and around as many times as we want. So if you wanted to find more coterminal angles, all you would have to do is take your angle and keep adding or subtracting revolutions as many times as you want. So a lot of times the formula might be written like this: angle plus or minus 360. The n just means really as many revolutions as you want. Okay, so you could keep going and going and going. So that's the basics of measuring in degrees. Now, there's another way of measuring and doing coterminals, and that would be in radians. Okay, now what is a radian? Well, radians are using the arc length of a circle and the radius to also measure an angle. So what would happen, I'm going to draw the same picture as earlier, and that was, what was that, a 110? Okay, so it's still 110 degrees. But if we wanted to know what that was in radians, the abbreviation, by the way, is rads, is you would take the angle you have and multiply by pi over 180. This is the conversion formula for it. And we don't need a calculator for this. We just need to reduce fractions. 110 over 180 would be 11 pi over 18. If I reduce this correctly. So that would be the radian measure for this right here. So I'm actually going to erase this and call that 11 pi over 18. Now, same thing as before. This is the positive radian measure if I were to go counterclockwise, CCW counterclockwise. But what if I wanted to go this way and figure out that coterminal, okay? Now, I know we did it above, and we could just take the 250 and also do a conversion, but if you don't want to have to convert and keep going back and forth, there is another way to do it, okay? We're going to take the formula that we did up here, and we're going to change it to go with a radian. So if you want to do coterminal angles, and you are in radians, instead of adding or subtracting 360, oops, that's a plus or minus. Instead of adding or subtracting 360, we're going to add or subtract 2 pi as many times as we want. And the reason we're going to do 2 pi is because an entire revolution is either 360 degrees or 2 pi. And you should know that already from class, okay? So for this one, if I'm like, well, I want to find a coterminal with 11 pi over 18, I want to know what that red one is, what I would do is just subtract the 2 pi, and that would give me the negative angle right here that I'm looking for. In fact, just so I don't confuse you, let me get this in green like it was above. So here's the green original angle. I'm going to subtract an entire revolution, and that's going to get me the red one. Okay, so how do I do this? Well, I need a common denominator. Right now this is over 1, so the common denominator is going to be 18. But if I multiply the bottom by 18, I have to multiply the top by 18. So that's going to be, what's 18 times 2? 36? Awesome. So whatever 11 minus 36 is, that's going to be our answer for this red coterminal angle. So I believe that's a negative 25. Y'all can correct me if I'm wrong. Yeah, I think I'm right. Okay. That right there, folks, is that red coterminal angle. So whether you're in degrees or radians, you can find coterminals. You just have to add or subtract the correct thing and make sure you're doing fraction math right. So there's coterminal angles, and there's moving around the circle either forwards or backwards, positive or negative. What else could there be? Well, we can talk about something called a reference angle. And these are important for many, many, many reasons. Reference angles, you want to think about basically like any angle on the circle and or on the coordinate plane and how it relates back to the first quadrant. So a reference angle, guys, is always in a first quadrant. So like if I were to give you, let's say 30 degrees, and I said, what's the reference angle for 30 degrees? The answer would actually be 30 degrees because well, it's already in the first quadrant. But if I gave you like something like this, I really like this angle today. We're going to keep that 110 theme going. Let's pretend that this is 110 right here. And I said, okay, what's the reference angle for 110? What you're supposed to imagine now, guys, is you're supposed to imagine, well, what if I was able to find where this angle lies in the first quadrant? So it's very much about symmetry. It's almost like you're going to imagine folding it across the y-axis and then seeing where it would go over here. So it would look to be about right there. But you need to figure out this. And the way you're going to figure out this is if you can figure out that on the other side. So how far away is 110 from 180? Well, it is 70 degrees away. So that's going to be the reference angle. It's going to be your how far away you are to the nearest x-axis. And if you can figure that out, you will find your reference angle every single time. So keep this in mind. Let's do another one in degrees, then we'll switch to radians. Okay. So let's do one maybe like right here. Okay, so let's say I'm in the third quadrant and somebody has told me that this is the angle, what is that angle? That looks to be about maybe 260. Maybe not that big, but we're going to call it 260. Okay, so if we know that we are at 260, our goal is to figure out our distance to the nearest x-axis. Well, look at you're either this x-axis or this one, and if you look at this line, it's closer to this one, right? So if I can find this angle right here, then I'll have my answer. So how much is this line worth? Well, this is worth 180, right? Because that's 0, so that's 180. So from 260 to 180, what is that difference, right? What's the difference? I believe it's 80 degrees. If I'm doing my math right, 260 minus 180. So that would be my reference angle. What if I'm in radians? Everyone always thinks radians is going to be more difficult. It's actually a little bit easier if you think about common denominators, and I'll explain that in a second, but this is kind of the key to doing these quickly. Common denominators. So I'm going to give you an example, but before I do, you have to know your radians for all of your axes. So like this is 0 radians or 2 pi, right? This is pi over 2, this is pi, and this is 3 pi over 2. So we have to know these from our unit circle, because if I give you something like, how about 13 pi over 11? Okay. 13 pi over 11, you may or may not know where it is. And that's why this common denominator thing is going to be so important. So I might draw it for you. You might get lucky, and I've actually drawn it in, and I've said, okay, 13 pi over 11. But if I haven't shown you that, you're going to have to know kind of where it is so you can figure this problem out. So what I like to do is take the denominator of whatever's given and make it happen everywhere on my circle. You know what I mean? Like, I'm going to go ahead and put these over 1 right now. I want all of these denominators to be an 11 to make this work. Okay? So I'm going to go over here. Since this is a 1, I'm going to make it an 11, which makes this 11 pi over 11. And over here, if this is 2 pi over 1, if I make the bottom 11, I'm going to make the top a 22, right? 22 pi. So just by changing those two, even though we haven't changed the other two yet, 13 pi over 11 should be just a little bit past this one, because this is like 11 pi over 11, so that might be 12 pi over 11, so that would be 13 pi over 11, okay? So that's one way of doing this. Now, this is so important because of what we said up here. I'm going to scroll back. Your distance to the nearest x-axis. Well, if you know that you're closer to this x-axis, then all you guys have to do is figure out how far is 11 to 13. And the answer is a big fat 2, right? 11 minus 13, or 13 minus 11 is 2. So 2 pi over 11. That would be your reference angle. Okay? And the reason this is so powerful, let's try one more and then we'll do the reason why. So how about this one? How about, let's do sketch and find a reference angle. Terrible handwriting alert. Okay, sketch and find a reference angle for, let's do like, how about 3 pi over 8? Okay, 3 pi over 8. So right now I'm going to label all these 0, pi over 2, pi, 3 pi over 2. So the first goal would be get a common denominator so that you know where this is located. So I need to make all of these an 8 on the bottom. If I make this an 8, the top becomes a 16. Right? Whatever you do to the bottom, do to the top. If I make this an 8, what am I multiplying by? I'm multiplying by 4. So the top has to be multiplied by 4. Over here, there's an invisible 1 on the bottom. If I make it an 8, the top becomes an 8. Here, I need to multiply 2 times 4, so the top becomes 4. Okay, so now that we've done these, we should be able to see exactly where 3 pi over 8 goes. If that's 4 pi over 8, then it's going to be a little bit less than that, right? So here is my angle. Now, a reference angle is the angle in the first quadrant that you refer back to. It's how far you are from the x-axis. So this problem, friends, is finished. It is its own reference angle because it's already in the first quadrant. If I had asked you to do 7 pi over 8, where would that go? Well, 7 pi over 8 would go a little bit, in fact, I'll do this in blue so we have some color coding. Okay, 7 pi over 8 would go about there, right? Because that's 8 pi over 8, so it's a little bit less. And then we would need the reference angle for that. So if I shade that in, it's this tiny little sliver. And the reason it's a tiny sliver is because the difference between 7 pi and 8 pi is 1 pi over 8. That would be its reference angle. So I hope this is making more sense now. Okay, so the reason you want to know reference angles is for the following. If I want you to find, let's say I've given you 70 degrees, okay? And let's say that I have given you the x and the y value at 70 degrees. And maybe I'm like, okay, hey y'all, what is the cosine of 250? But I don't give you a calculator and I don't give you anything on this part of the circle. Well, if I ask for the cosine of 250, remember cosine would just be the x value at 250. And if you look at where 250 is, it's straight across from here. So in other words, its reference angle is 70. And because of that, I know that the x value at 250 is going to match the x value at 70, and the only difference is I'm going to put a negative on it. So whatever this answer is, it'll stay the same number, and I'll just put a negative on it instead. So one thing I might ask you to do, especially if you're in pre-AP, it'll be like a true-false, where I'll say the cosine of 250 is equal to the cosine of 70, true or false. Now this one would be false. But if I wrote it as this, then it would be true, because I'm taking the x value at 70, and if I make it negative, it will match the x value at 250. So it's all about symmetry and knowing your reference angles. All right. One last little thing to go over with reference angles. And if you're not in pre-AP, you can actually probably stop watching the video right now. You might not ever need to know this, but it's on the SAT sometimes, so you might want to watch. Something I want to remind you guys of is that when we did our 30 and our 60 for the unit circle, remember how they formed the same triangle so that whatever was the x and y here just switched places whenever we moved up to 60? I hope you guys remember that. That's important, because if you understand that, then if I gave you something else, like if I gave you maybe 10 degrees, and I started talking about 80 degrees, I want you to understand that the 80 and the 10 would have the same exact relationship. Why? Well, if I made a triangle out of them, it would be a 10, 80, 90 triangle. So no matter where, as long as you notice that the distance to the y and the distance to the x are the same, they would make that same triangle, and that's going to be important because I might do something like this. True or false, the cosine of 10 is equal to the cosine of 80. So I'm asking, is the x value at 10 the same as the x value at 80? And you would say false. And if I said to make it true, all you'd have to do is change this to sine. Why? Because the x value at 10 degrees would be the same as the y value at 80 because of this rule right here. When the triangle flips up on its side, the x and the y change places, just like they did on the unit circle. So let me try to make one a little bit more challenging. True or false? How about the following? How about the cosine of 100 degrees is equal to negative sine 80? All right. So 100 degrees and 80 degrees are in different places, right? And actually, let me change that because that's a false. This is probably still false, but I at least want us to have to think about it. I meant to do 170. Okay, 170. Let's do this one instead. The cosine of 170 is equal to negative sine of 80. All right, 170 and 80, if I drew them, they are not in the same quadrant, and that might confuse some people, but this is why we use reference angles. 170 is here, 80 is here, okay? How far is this from the x? Well, it would be 10 degrees, right? So its reference angle would be 10 degrees. These are kind of like matchy-matchy, so it's almost like the question I did a second ago. So if we think about it, okay, whatever the x and y are at 10, it's going to match on this side, right? The only difference is that this is going to be negative. And this xy, how does it relate to 80? Well, if it formed the same triangle, this is now the yx. So things got switched. So is the x value at 170 equal to the negative y value at 80? Yes, it is. This is a true. Now this is a hard concept and you might need to see me one-on-one about it, but I did want you to get to see it and hopefully that made some sort of sense. This is everything I can think about for moving around the circle, reference angles, coterminal angles, and measuring positive or negative. So hopefully this will help you out if you did not understand it so much. Oh my gosh, that's terrifying. Don't look at that. If you didn't understand it in class the other day, hopefully this helps you with your assignment now. Thank you.